Section 4.4, we're going to take a look at other bases, not from a historical perspective, but just a numerical perspective only. And we're specifically going to be looking at converting between bases in this section, okay? So our leading idea is the following. Converting between number bases requires understanding the same value expressed in different systems. You guys do this with some things already. I'll mention that in a minute. This reminds us that faith in God often calls us to recognize that spiritual truths may be expressed and experienced differently across cultures, traditions, and personal journeys. Yet, they point to a single truth. Just as conversions help us to translate numbers accurately between systems, faith in God allows us to see diverse experiences in our lives in relation to His truth. So one of the things that my husband likes to talk about, he's a pastor, as we've mentioned before, if you remember, is that there's no people group on the earth at this point who has not heard some form of Jesus. There's not. And even when there were, like those people groups, right? God in His mercy has revealed parts of His nature to them through whatever faith that they had before that as well. They have seen glimpses. They have seen pieces of God at work in their lives. Now, when it talked at the beginning of this about, and I mentioned that we do this already, one of the places where you do this is in measurements of length. So have you ever been to an amusement park? Raise your hand if you've been to an amusement park, state fair, something like that. And there's usually height restrictions for who can ride the ride, right? What are those height restrictions usually in? Do you know? Inches. They're usually represented in inches. And when you're little, they often measure your height in inches. Does anybody know your height in inches?
Like 71 inches.
71 inches. Okay, so most of you are like, what is she talking about, height in inches? How do you usually measure your height? Feet and inches, right? So could you figure out how many inches you are?
Yeah.
Well, of course you could. Absolutely, right? My daughter's just about 5 foot. She's really close. So if she's 5 foot, how many inches is she? 60 inches. And how'd you do that? Multiply by 12. You did a conversion. You did a conversion from feet into inches. Okay? So we do this with that particular measurement a lot, actually. Okay? So at least you've done it frequently. So we're going to take a look then at our base 10 number system and then move forward into some other bases to see how they work in conjunction or by comparison. Our base 10 number system actually starts with the number 1. I'm going to write down the number 0 because I think it helps us to see all 10 of our digits if I start with 0. So I say that because I want you to know that when you see this in my math lab, they're going to start with 1. That's fine, but for the purposes of seeing all of our 10 digits, I think this helps. We have 10 digits. We do not have a digit 10. We have a number 10. We don't have a digit 10. Digits are single, right? You talk about your fingers and your toes as digits, right? They're single counts, okay? So these are our 10 digits. And we run out of digits, we have to do a 2-digit number, and we start back over by starting with the 1 on the left-hand side and then the 0 on the right-hand side, okay? And we keep going until we get to, 19, and then we trade up again and we go to 20, correct? All good so far. What's the biggest 2-digit number in our base system? 99. And then after 99, we get 100, a 3-digit number, and we keep going, right? Forever. Okay, so what happens in base 5? Well, first of all, you should remember that I said there is no 10 digit in base 10, right? We have a way of writing the number 10, but it's with 2 digits. All good so far. It works the same way in all other bases. There will be no 5 in base 5. Please write that down. No 5s in base 5. There's also no 6s, 7s, 8s, or 9s. But usually it's the 5 that's the hard one for us to think about. No 5 in base 5. Because there is no 10 digit in base 10. Okay? So if there's no 5s in base 5, it means we start with 1, and where would we stop with our digits? 4. Are there 5 digits written there? Yes, there are. They start at 0, they end at 4. There are 5 digits. So again, if my math lab asks you to write the first X number of digits, like the first 10 digits in base 5, they're going to start with 1. Okay, so start with 1. That's fine. but 0 allows us to see the 5 digits. So that's why I'm going to write it on the screen. Okay, you good with that? Okay, when I run out of single digits in base 10, I had to create a 2-digit number, right? And my 2-digit number became the number 1 in the tens place and 0 in the ones place. Yes? Good so far. The same thing happens in base 5. When I run out of single digits, which I have, I will put a 1 in the 5's place, 1 in the place over, and a 0 in the ones place. And I have 1, 1. And then I have 1, 2. And notice I'm not saying 11. It's not 11. This is not base 10. It is 1, 1. Okay? 1, 1. And then I have 1, 2, and 1, 3, and 1, 4. And what happens is I run out of digits. What's going to come after 1, 4? Close. 2, 0. 2, 0, and I keep going. What is the biggest 2-digit number in base 5?
4, 4.
4, 4. Yeah, it's 4, 4. And after 4, 4, I get 3 digits. 1, 0, 0.
So you still have
Oh, yeah.
Okay? So this is actually one of those places that kids, this is where I was trying to remember from earlier, but it's in this connection, not what I was trying to before. If a child is working and they have 28, 29, you will sometimes hear them say 2010, 2011. Have you ever heard a child do that before? Yeah? Like, it's sort of ingrained in how we think about numbers, right? Is that just keeps going. And since we had the ones and 11, 12, 13, we're just going to keep going, right? But it doesn't work that way. We don't have a 2011. We run out, right? And we become the number 30. Right? It's the next number after 29 is actually the number 30, not 2010. Okay, how about base 7? Follows all the same rules, starts with 0. What's the biggest number in base 7? Numeral. It is a 6. So what's going to happen after the number is 6 in base 7? 1, 0. All the way to 1 what? 1, 6. So if I keep going after 1, 6, what's the next numeral? Or next number, excuse me? 2, 0, yeah. What's the biggest 2-digit number in base 7? 6, 6. And then after 6, 6 would be 1, 0, 0, and we keep going. Okay? How about base 12? Base 12 is different. What makes it different than the ones we already did?
Because it's more than 10.
It's more than 10. The ones we've done so far are less than 10. All good so far. This trips people up too. So we actually don't have enough digits in base 12 based on our base 10 system. What's your question?
For base 10,
Yes.
would you just go to 1, 1, 1?
On base 10,
I mean, yes, I'm just curious.
after 100?
Yes.
What comes after 100 in base 10? Don't overthink this.
101.
101. It just changes the last digit only. So it increases the last digit. So you're just increasing the last digit each time. Yeah. Okay? That happens sometimes. When we start thinking about other bases, we lose track of our own. So yeah, it can happen. So what are we going to do in base 12 when we don't have enough digits? Well, the first thing we're going to do is we're going to write down all the digits we do have. 0, 1, 2, 3, 4, 5, 6, whoa, wow. 6, 7, 8, and 9. So we're going to get all of those, but we need more. We need a 10 and we need an 11, and there's no 12 in base 12, okay? So different resources do different things. This book, this resource goes to the letters of the alphabet and it goes in order. And I actually think that's better than the other resource that I use. Were you in number 3 with me? Yeah, it does something different, doesn't it? Yeah. Okay, so we're going to go to letters. So we're going to, our first letter is A, and our second letter is B. And up here in a different color to remind ourselves, I'm going to remind us that this is the number 10. I'm going to write it in words, and this is the number 11. Okay? It holds the number 10. It holds the number 11. Yes?
I'm confused. Why don't we just write the number?
Because then we'd have a 2-digit number, and I need 1 digit. I'm still working with 1 digits. So in base 7, I have 7 digits. In base 12, I need 12 digits. If I go to 1, 0, I've used 2 digits. I need a 1-digit number. And I don't have anything to represent them, so I'm going to use my alphabet. A and then B. So if I had base 16, I'd keep going, C and D, however more I need. Okay, that's what it will look like. your book, your resources are not going to go to crazy numbers. It's not going to go up to like base 20. That's not going to happen, okay? So I think it might go up to base 16. That's usually about as big as they go. By the way, bases are used, not only did I gave you an example of inches and feet, which is one of the places where you see bases used. Your clock is in bases. It doesn't reset on the number of digits, but we do minutes and hours, right? 60 minutes is an hour, 60 seconds is a minute. It's a base 60 system. We just use 2 digits for it. We have all of your calculators, all of your phones. They're built in binary. You heard of binary?
Yeah.
Okay. Binary, 1s and 0s only. There's only 2 digits in binary. Bi means 2, right? Binary, 2 digits. Hexadecimal, which is base 16, is also computer programming. So you've got 16 digits in base 16. But the one, of course, you're most familiar with is base 10. Okay, so let's take a look at what happens then when we're working in these other number systems and we do some of the things that we did in our historical numeration systems. The first thing we did when we were looking at them is we talked about what's the number before and what's the number after. Do you remember doing that? We're going to do the same thing with these base systems. Usually, one of them is real straightforward and simple, and you're like, well, obviously. And the other one is the one where it crosses over into territory you're not supposed to touch. Okay, so let's try the number 1-4 so you can see. What comes before 1-4? 1-3, right? I've got 1-3. Notice the subscript next to it tells us I'm in base 5, so it's 1-3 base 5. 1-4 would be next, so I'm going to write it in as a reminder to us. And if I go next, I'm crossing into that territory I'm not allowed to put. I can't put 1-5. Why not? Because there's no 5s in base 5. They don't exist. So what happens? What follows 1-4? 2-0. It says 2-0 base 5. Okay? Let's try the next one. This is A00 base 12. Can you tell me which one is the natural, easy one to do, the before or the after? It's the after. What comes after A00? A01. Okay, so this kind of goes back to your question, Jeremiah. When I'm going beyond 100, right, I get 101 in our system. So when I'm going beyond, I always change the last value only when I can. The last value is a 0. I can increase it by 1. So this is A01. And this is base 12. Now the number before is harder. Any idea what might come before A00? Close. So 999 was a thought. That's close. It's close. It's not A99.
A9?
No.
Is it just 99? Is it just 99?
Okay, let me just tell you, it doesn't have any 9s in it.
Oh.
Yes. Ooh. Now I've got a face.
Wait.
Doesn't have any 9s in it. Ellie, what do you have?
9BB.
Oh, it has the first 9. Sorry, I missed thinking about the end of it. You are correct. It is 9BB. So let's talk about why, but that is correct. It is 9BB. Okay, I want to go back to our system where you're a little bit more comfortable so you can see what happens, and then we'll do the parallel into this system. So let's say we started out with the number 800. Can you good with it? Good with that?
Yeah.
Okay, so what happens in the number 800? Well, we take the 8 at the beginning and we decrease it by 1. What's before 8? 7. Okay, that's what we did here. We look at the number A. It is a number for the purposes of this discussion. The number that comes before A is 9. Okay? Y'all with me? Okay, and then what do we do with 800? Well, what do these zeros become? Okay, they become 9s in our base system, right? They would become 9s, which is why everybody wanted to turn my zeros here into 9s. So you weren't wrong in thinking about that. It's just that 9s aren't the biggest thing we have in base 12. 9s are the biggest thing we have in base 10, right? That's why they became 9s. What's the biggest value we have in base 12? B. So this is 9BB. Are you uncomfortable? Good. Some of you. Some of you are like, no, I'm good. Hopefully you're actually a little uncomfortable. That's my goal. That's my goal today, make you a little uncomfortable. You okay? Okay. What number is that? Okay, we're going to do that here in just a second. What number does this represent? Okay, that's where we're going to head next. We're going to actually convert. Do you have a question, Jonathan?
Yeah, so if it was 13, would it be 9cc?
If it was 13.
Like if it was,
Oh, base 13?
yeah.
On that one, yes, it would.
Okay.
Yes. Yes.
So the reason why it's B is because B is bigger than A?
Well, yes. B is the biggest number in base 12.
Why does it be A0?
But that'd be bigger than we started with. If you go doubling up, if you give me a 4-digit number, we're bigger than we started with. Okay, so let's hit on Jordan's question then, is what does that mean in our base system? So that question is equivalent to asking, if I took one of these weird numbers and I turned it into a base 10 number, what would it look like, right? Okay, so we're going to do this with base 2 to start with. Okay, so what we're writing down initially is going to look familiar because we've done it before. We did it with the Babylonians and we did it with the Mayans. Each of these is a place value, correct?
Yes.
Yes, and we did actually in last section too when we looked at our base 10 expansions. This number 1 is being multiplied by some power of 2, and the 0 is being multiplied by some power of 2. And we have our next 1, being multiplied by some power of 2, and our last one is multiplied by some power of 2. Okay, how do I know they're powers of 2? Why am I saying powers of 2? Because this says base 2. This right here tells you that all of these things are going to be 2s. Okay? Our system, we wrote these as 10s. Do you remember doing that at the very beginning today in 4-3? Yes, we did. We wrote powers 10. And then we actually can start on the far right with the number 0, and we can just increase. 0, power 1, power 2, power 3. They always increase from right to left. Your calculator can do this very quickly. What's 2 cubed? 8. What's 2 squared? 4. 2 to the 1's 2. And what's 2 to the 0? 1. 2 to the 0 is 1. Anything to the 0 power is 1. So I have 1 times 8, that's 8. I have 0 times 4, that's 0. 1 times 2 is 2. 1 times 1 is 1. 8 plus 0 plus 2 plus 1 is 11. 1, 0, 1, 1 in base 2 is the same as 11, and it's in base 10. I'll write the 10 next to it just to remind you when you look back at your notes, not because you need to write the 10 there, okay? So draw yourself a note that says this is not needed. I do not need to write 10 when it's base 10, but I want you to remember that's what we did. That says 10. That's my word 10 when I'm trying to write really tiny. Okay, yes,
So is answer number 3, is that just the binary version?
yes.
Okay.
This is the binary version of our number 11, correct? Yes. So in your calculator, in your phone, if somebody who's programming this wanted to somehow code into your calculator the number 11, that would be coded in as 1011. Ons and offs. Okay? Yes.
So the answer would be 8 0 2.
The answer is 11. It's boxed in at the end. The answer is 11. Yeah. Okay, there is a shortcut for how to do this in your calculator. I don't love this, and if there was a way that I could sort of separate the questions in my math lab to not include it, I would, but I don't have any way to separate it. They include it all as one question. You get it or you don't. Okay, I mean like you, not points wise, but I mean like the question has parts to it, and it's one of the parts, the calculator shortcut. So let me show you how the calculator shortcut works. Maybe you'll love it, and if you do, that's great. Okay, so I'm going to move this up so I have some more space, maybe at least a little bit, and I'll change colors to try to distinguish that I'm doing something different. Okay, the way that this works is this. We take the number 1 at the beginning, and we multiply it by 2. Everybody's good so far. We're in base 2, that's why we're multiplying by 2. The number 1 comes from the number 1 at the beginning. Everything good so far. And then we're going to add the second number here. That's a 0. And then we're going to put parentheses around that. And we're going to multiply it again by a 2. We're going to add the next number in our list, which is a 1. We're going to put parentheses around all of that, and we're going to multiply it by 2. And then we're going to add our final 1 at the end. If you're careful putting this into your calculator with all the correct parentheses in the right location, and you press enter, it will also give you 11. Let me just talk about why it works. Even though I don't love this, there's a reason why it works. What's happening here is that this 1 at the beginning, that's 1 times 2, gets multiplied by 2 here. That's 1 time. Here, that's 2 times. And here, 3 times. That number 1 is getting multiplied by 3 2s. Okay? The 0 here, there's only one 0 in my problem. This 0 is getting multiplied by a 2 here. That's 1 2. And by a 2 here. That's 2 2s. That's 2 squared. Okay? This is what the calculator shortcut looks like. Some of you are like, nope, don't like that. I don't like this. I don't think it's not very intuitive. It's not very helpful. But it is a shortcut. Let's look at another one. This is in base 16. So we see lots of letters, A, B, C, D. I'm going to write this out a little more explicitly with some blanks. So in base 16, we'll start with the most familiar one. What is the number A representing? What number? It's 10. I'm going to put 10 right here. I'm going to put a 2-digit number in a 1-digit spot because it's going to help us think about it. That's why I'm doing it. What is the number B in base 16? 11. What is C in base 16? It is 12. And what is the number D in base 16? 13. These are the values they represent as 2-digit expressions. Okay? 12 inches, 1 foot. It's the same thing. If I use 1 foot, I use 1 digit. If I use 12 inches, I got to go with 2 digits, right? What place value are each of these? Well, it's base 16, so this is 16 to the 0. 16 to the 1. 16 squared and 16 cubed. Okay, that's the place values each of these are. And then notice what we did up here at the beginning, right here. We multiplied each number by its place value. So this is 10 times 16 cubed plus 11 times 16 squared. 12 times 16 to the 1 and 13 times 16 to the 0, or you could just write that as 1 if you wish. Now, I'm not going to belabor the point to write out all these powers of 16. You can if you wish. Your calculator will do it for you as well. Okay? It's fine. But in the end, I need to do some multiplication, and then I need to do some addition. It's going to all compile together to give me a single value, correct? Does anybody have that value of what it shows up to be? Does anybody know it?
Wait, 16 cubed or 16 cubed?
I wanted to get to the very end because I'm out of time. Like if I multiply 10 times 16 cubed plus 11 times 16 squared plus 12 times 16, like all of it together.
43,981.
There you go. This is 43,981. Let's write the calculator shortcut in your notes, even though we don't have to like it, okay? Y'all ready for that? Let me shift this around so it's in your notes. This is going to move. This is going to move. We're going to write it out in yellow. We take the first number, A, which is 10, and we multiply it by 16. Am I still on screen? Barely. Okay. And then I add the second value, which is B, which is 11, and I embed them in parentheses and multiply by 16. I add the next number, C, which is 12. I embed them in parentheses and I multiply by 16. And then I add the last digit, D, which is 13. And I can type all this straight in the calculator, and it will also give me 43,981. Okay, so here's what I'd like to do. I have a few more examples, but I really don't want to post a video that you have to watch because I feel like doing this in person is going to be more significant and more helpful. Okay? The problem with this, and you need to understand the problem with this because it's a significant problem, is that if I don't make this due on Tuesday, it's going to be due next Thursday, which means on Thursday you're going to have this due and you're going to have a test. If you wait to do this entire assignment until Wednesday night, your test is not going to go well for you. Okay? So your responsibility, if you choose to accept it, is to do everything in this section that changes numbers in base whatever into our base and to stop. Do not do the quiz. If you do the quiz, it's an open shut thing. Homework, you open it up, you work on it, you can turn it on and get it off, right? And you can come back in later. So your assignment between now and Tuesday, which is totally on your plate as to whether or not you do it, is to do as much of this assignment as you can. And then I will talk about the rest of this and the first probably 10 minutes of class, 15 maybe, and then we will do a review. Does everybody understand? And on your honor, you're going to do your very best to do what I've asked, right? Absolutely.